Hi, today I want to show you guys how to multiply binomials, a lot of them, using a shortcut. And to show you how much of a shortcut this is, I want you to try to begin class by multiplying a plus b to the fourth power out by hand. And I'll actually encourage you to pause the video because it takes me a while to do this, and so I didn't record it all. Pause it, try it on your own. I'll get you started. A plus b to the fourth power. What that means, remember, is a plus b times itself 4 times. So a plus b times a plus b times a plus b times a plus b. And so at this point, go ahead and pause the video and try to multiply this out. Now, hopefully you've had a chance to try that. And I've written my answer up here on the board, and I did it one multiplication at a time, which might not have been the most efficient way, but that's what I got. And I wanted to show you just something really kind of interesting, I think. If we look at the final answer has a bunch of different terms of a's and a bunch of different b's. I want you to notice the powers of a seem to go down by 1 each time. 4, 3, 2, 1, and then no a's here, while the powers of b naturally go up by 1 each time. That's kind of interesting. But I want you to look at the coefficients of each of these terms. The a to the fourth term has a coefficient of 1. The a cubed term has a coefficient of 4. The a squared term, 6, and then another 4, and then a 1. 1, 4, 6, 4, 1. Now, those numbers I've seen before, and I think you've seen them too. The other day, we talked about the Pascal's triangle, and I want you to notice those numbers, 1, 4, 6, 4, 1, are one of the rows of Pascal's triangle. And in fact, the step before that, which was really in red, we have a plus b to the third power. Notice the numbers 1, 3, 3, and 1. Those are another row of Pascal's triangle. And the term before that, which was a plus b squared, was 1, 2, and 1. And there's a row of Pascal's triangle as well. This is true for any power, that the coefficients also often involve some variation of Pascal's triangle. So, in general, you can multiply any polynomial, any binomial raised to a particular power by using this particular rule, which is kind of obnoxious with sigma notation and all that sort of stuff, but each of these terms does work. In summary, each term, there'll be n plus a 0th term, so n plus 1 terms. Each one of those terms is going to have a coefficient, and that coefficient is one of the numbers from Pascal's triangle. And then the a chunk, which is often a variable, but not always, that a chunk will have a power, and the b chunk will have a power. Those two chunks, when you add them together, are always going to be n. One of them is going to go up, one of them is going to go down. So, in short, these bullet points kind of summarize this process. The coefficients are always going to come from Pascal's triangle. Look at the nth row of Pascal's triangle. The powers for one of the terms are going to go up, and the powers for the other term are going to go down. And every once in a while, you might have a subtraction problem instead of an addition problem. If you have a subtraction problem, I would treat that second term as a negative object, and you can use this same idea, but negative b to the nth power. And in short, those are going to end up alternating signs. Every other term you'll either add or subtract. Here's a problem, x plus 5 to the 7th power. If I want to expand this using this shortcut, here's the way that I do it. This is two different chunks. I've got a and b, or in this case, the letter x and the number 5. So I'm going to start by writing x to the 7th, and then x to the 6th, and so forth, just each time going down one chunk. I'm leaving myself some space because I've got more things to add to each of these different terms. I've got the 5 factors, and I've got the coefficients I need to add to these terms. Then the numbers, the b part, those are going to show up in every term as well, and they're going to be going down or going, I guess they're going to be backwards. And so I actually write these backwards and start with the very last term. Won't have any x's in it. It'll just be the number 5 to the 7th power. And then the term right before that will be the number 5 to the 6th power. The term right before that will be 5 to the 5th power. Notice how in each case these exponents, 2 plus 5 is 7, 1 plus 6 is 7, this is 7. That'll always be the case because n is 7. And so the x cubed term will also include 5 to the 4th. The x to the 4th would be 5 cubed. X to the 5th will be 5 squared. This guy will have a 5 to the 1st power in it. And the very first term is all x's. There's no 5s at all. It's really 5 to the 0th power, and so it still adds up to a power of 7. And then the last part of this is that each of these guys needs a coefficient, and the coefficients come from looking at the 7th row in Pascal's triangle. So 7th row of Pascal's triangle is this guy. And so I'll write those numbers in front. 1 times x to the 7th, 7 times that guy, 21, 35. And remember, Pascal's triangle is symmetrical, and so once you've gone about halfway, you can write those same numbers backwards. So the expansion of x plus 5 raised to the 7th power is whatever this expression becomes once you clean it up a little bit, once you simplify it. For instance, this first term is actually pretty simple already. There's not much to do. It's just x to the 7th. This guy, there's a 7 and a 5 factor. If we multiply those together, you get 35 x to the 6th. And I'll go ahead and do the rest of these. I might recommend you pause and try to determine them on your own. After filling in all the rest of these, there ends up being 8 different terms with a bunch of different numbers, some of which got really big. So 1x to the 7th, 35x to the 6th, 525x to the 5th, 4,375 x to the 4th, 21,875 x cubes, 65,625 x squareds, 109,375 x's, and 78,125. So it was so big I couldn't even fit it all on one line. There's a lot of times when instead of trying to fully expand this whole thing, we're actually just interested in 1 or 2 terms of it. And so I know in your homework you're going to see a couple problems where it says find the coefficient of the x squared term, and so that would just be looking at this guy. And so I always write out this long expansion and then just simplify whatever's needed. Maybe that's the whole thing, or maybe it's just a small piece of it. But there's x plus 5 to the 7th. As a reminder, you can check your work with this if you want. If you type some sort of random number in for x and type x plus 5 in parentheses raised to the 7th on your calculator, you'll get something out of it. And if you go ahead and type this big long thing, which is your answer, out, assuming you haven't changed what x is equal to in between, you should get the same weird random number out. If that checks out, then you've expanded it correctly. One last example chosen because it's got the minus in there, and how does that affect things? This one won't be quite as long, but to expand this one out, I'll take 4x and the chunk minus 3y, and I'll write each of those out with various powers. So in parentheses 4x to the fourth, then 4x cubed, then 4x squared, then 4x to the first, and then 4x to the 0th, we don't actually have to write. And then I'll do all the minus 3y terms. Minus 3y to the fourth, minus 3y to the third, minus 3y squared, minus 3y. And then the coefficients come from Pascal's triangle. In this case, the fourth row is 1, 4, 6, 4, 1. We've seen that before, haven't we? 1, and then 4, and then 6, and then 4, and then 1. And when you end up simplifying each of these different terms, you'll notice that some of those terms end up being negative because there's, for instance, this guy here. This term's going to end up being negative because there's just a single negative factor in here. And this guy over here is going to end up being negative because you've got negative 3 to the third power. Negative 3 times negative 3 times negative 3 is that. The even-powered terms, those are going to end up being positive because you have a positive number. It's going to be an even number of negative finds, and so that calculates out to be a positive. So if you want, you can pause it a second, and then I'll write in what these final answers are. After multiplying that all out, this first term, the x to the fourth term, has a coefficient of 256. That's just 4 to the fourth power. Then minus 768 x cubed y. That's what we get from 4 times 4 times 4 times 4 times negative 3. 6 times 4 times 4 times negative 3 times negative 3 is 864 x squared y squareds, and ending with minus 432 x y to the third powers plus 81 y to the fourth powers. So there's a couple quick examples of taking binomial multiplications and hopefully saving you a little bit of time multiplying them out so you won't have to FOIL and FOIL and FOIL and FOIL over and over and over again until you get it worked out. So hope that helped, and I'll see you tomorrow.